Hi guys, welcome. Now that we know what a mixture is, we're going to try to figure out how to separate it into its individual components by using different physical and chemical methods. This would be mixture separation methods. So one of the first techniques that we'll see is filtration. We tend to use it in our daily lives, for example, to make tea or coffee. So the idea here is that we're going to separate an insoluble solid from a liquid. This is based on particle size because what you are seeing here is the use of a filter paper. So with this filter paper, based on the particle size, we're going to keep those particles that are bigger, and then the water can come through. What's left in the filter is known as the residue, and the liquid that we obtain from it is known as the filtrates. In this image you have here, you're seeing the adaptation to the lab technique. The only difference is that we need a filter funnel and we need a beaker. So if you had, for example, a mixture of water and sand, knowing that the sand would be the solid we wish to separate, and the water would be the liquid. So we have a filter paper which is adapted to our filter funnel, and then the sand will be kept in the filter paper because the particles from sand will be smaller compared to the pore of the filter paper. And then the liquid water here can pass through. So here you have the residue and the filtrate. Another method that we can use to decantate, we can use to separate, is decantation. So when we decantate, what you're seeing here is, again, an insoluble solid from a liquid, but the property which we exploit here is the density. So we know that sand has a different density from water. So based on gravity, it stays at the bottom, and then we can just pour the liquid in order to separate these two. The only problem with decantation is usually effectiveness, because sometimes it's harder to separate the two components. So decantation can be used for separating either solids from liquids, which have a difference in density, or also liquids from liquids. For example, oil and water, by using a decantation funnel. Sieving is a method very similar to filtration. The difference is that when we talk about sieving, we are considering the separation of solids. So this one is also based on particle size. Instead of using a filter, we use what we call a siever. And this is the technique that we use. So what's going to happen is that those components that have a smaller particle size will come through the siever, and the bigger ones will stay. This can be used in construction, for example, to separate the different components of gravel or cement. This is widely used in the pharmaceutical industry when they are making tablets, so as to filter the different components that will make up the tablet. When we're usually making a tablet, the first components are powders. So it is important to have this powder separated based on particle size. That's why we use a siever. Another important method is evaporation. What we are separating here is, again, a solid from a liquid, but in this case, the solid is soluble in the liquid. The property that we are exploiting here is the difference on boiling points, because when we use evaporation, what happens is that our solid has a higher boiling point compared to that of water, which is usually used as the preferred solvent. So let's take a look. What you're seeing here is the solid being dissolved in water. We evaporate, so the water turns into gas, and what's left behind is the solid. This is usually used for purification processes. The disadvantage of this method is that in the end, since the water is evaporated, whatever liquid you use to make the separation is kind of lost in the process. So one consideration you should have when evaporating is that what we need to keep in the end is only the solid. So that's what we want to recover from the process. So here, the entire amount of water boils and evaporates, and we are just kept with the solid in the end of the process. Another important method is distillation. In this case, one difference comparing it to the other methods that we just checked is that distillation is only used for liquids. What we use here is precisely the difference on boiling points. So the liquids that we have in the mixture need to have different boiling points. In this case, we're using evaporation and condensation, because what happens in the beginning is that the liquid that has the lower boiling point will evaporate first. But when you come to this column here, this is connected to water, and the water is cold. So when my evaporated liquid comes through the column, this being colder makes my liquid condense again. So then I can catch it afterwards through this column. We have two main ways of distillating. We can have a simple distillation or a fractional distillation. What is the difference? In simple distillations, the difference of boiling points are really big. So then this means that I can easily separate those liquid components. In this scheme, what you see is the whole equipment we use in the lab. One example of this applied to real life is the distillation of salty water that we extract from the sea to purify it. So basically, salt has a really high boiling point, more than 800. And then water has a boiling point of 100. So what happens is that water evaporates and then comes here, and we can obtain it through the distillation column once the vapor condenses when it's cold, and the salt will stay here. As we know, distillation is widely used in the brewing industry. So as to obtain alcohol beverages, especially, for example, tequila, vodka, etc., those that have a high content of alcohol. And in the case of fractional distillation, we use it when the boiling points are not so further apart. So we need different condensing columns that have small particles in which they are usually made of glass, so that the liquid evaporates and condenses over and over, and this tends to separate better the fractions. Fractionate distillation is what we usually use to obtain petroleum. For example, you know that when we have the crude oil, there are different components within it. So in order to have these products, we need fractional distillation. Another method would be centrifugation. In centrifugation, what we use is centrifugal force, and we can use as an advantage the difference in densities, size, and shape. So what we're going to increase is the rotation speed, and then we have a specific sedimentation rate that depends on whatever we want to separate. Therefore, the components which have the bigger densities will stay in the bottom, and then the ones with the lower densities will come on top. We usually use it to separate liquids from solids, and this is a common procedure in lab, for example, to separate urine sediments when you're making a urine test, or in blood, so that we can separate the plasma from the cells, the white, red cells, and the platelets. And we also use it in the food industry to separate dairy components. So you know that, for example, in milk, you have skimmed milk that has less component of fat compared to regular milk. That is actually gotten from centrifuging the milk products. Chromatography is another procedure. We have different types of chromatography. What you're seeing here is an example of a paper chromatography. Now, chromos comes from color, and this is called chromatography because it was used in the beginning to extract the components of colored pigments, for example, chlorophyll. So what's going on here is that you need a stationary phase, which is in term paper in this particular example. We have a mobile phase, which would be the liquid, the solvent that you use to separate. And we need a column or a planar. This one is planar because we are using paper as the separation method, but we can also use it in column, for example, to separate proteins. Chromatography is based on adsorption, which is a chemical characteristic in which my components will interact. So if I'm separating chlorophyll, chlorophyll will be stuck on the paper first, but then it would interact through adsorption with the mobile phase, which is usually an organic solvent, and then that will make chlorophyll move from the rest. So what we do in paper chromatography in particular is to measure the distance between the application of the sample and our different stains that we have as a result. This is widely used as a purification method because each component moves differently based on this adsorption, and this is referenced in books or tables. So we know that when my component is pure, it will move X amount of centimeters, and that's how we know what components we have in the sample. We also have different types of chromatography. We can use gas chromatography, in which the mobile phase is usually a gas, and this is used, for example, in forensics to know what components were found in samples or to recognize different components in a crime scene. And that is all. I hope you liked the explanation of the different methods, and we'll see you next time.